Hello, night travelers. Welcome back to the Night Observer, a quiet place where weary minds come to rest, where comfort is found in stillness, and where we gently contemplate the vast and mysterious universe. The fire is lit once more. We gather again in its soft glow, warming our thoughts as we listen to stories written in starlight. Tonight, our journey carries us far into the distant past, toward the greatest event in cosmic history, the Big Bang. We will speak of the universe before it began, of humanity's long quest to trace its origins, and of the mysteries that remain unsolved. Together, we sit beside the light of creation, allowing our spirits to drift back toward the most ancient and primal moment of all. Let your body sink deeply into the comfort of your bed. Feel the pillow gently supporting your neck, the blanket easing around your feet. Let your shoulders soften. Take a slow, deep breath and release it just as slowly. Sense the space around you gradually dissolving until only this voice remains, accompanied by the quiet rhythm of nothingness. Tonight, we journey toward a land untouched by human footsteps, the universe before time truly found its pace. We devote our full attention to dreams in silence. This chapter speaks of humanity's yearning for connection, of the dark stars hidden within 18th century mathematics, and of the extraordinary efforts made by curious minds to peer through the invisible wall of the past. Let your thoughts grow light and allow this story to carry you gently towards sleep. Human dreams, the long night of a still universe. For thousands of years, humanity gazed upward and believed the stars were eternal. The notion that the universe might have a birthday, that it could have begun at a single moment, once felt impossible, even unsettling, to the greatest scientific minds. At the heart of this story lies an ancient fear: solitude and the weight of cosmic silence. Arthur C. Clarke once captured this unease with quiet precision. There are two possibilities. Either we are alone in the universe, or we are not alone. Both are equally terrifying. The search for the universe's beginning is, in many ways, a search for our own place within the endless flow of existence. Ancient astronomers gazed upon the Milky Way, called the Silver River by the Chinese, and the backbone of the night by the Kalahari Desert people, and imagined a universe that was fixed and unchanging. They could not yet conceive that space itself might be alive, slowly expanding, gently breathing. Dark stars, seeds of doubt. Long before the invention of modern telescopes, human intellect had already begun to sense the presence of darkness. In 1784, the English clergyman John Michell proposed a daring idea. If a star were massive and dense enough, its gravity could become so strong that even light would be unable to escape. He called such objects dark stars. A decade later, Pierre-Simon Laplace arrived at the same conclusion independently. Yet this insight arrived too early. In the 19th century, as light was understood to behave like a wave, the idea that gravity could imprison light waves seemed unlikely, and the concept faded into obscurity. It would take more than another century, until Einstein's theory of general relativity, for the door to black holes and cosmic singularities to open once again. Resistance to a beginning. During the 1920s and 1930s, most cosmologists still favored a steady-state universe, one without a beginning or an end, where matter had always existed. Even Albert Einstein, the architect of modern cosmology, initially altered his own equations to preserve a static universe. Arthur Eddington, one of the era's most influential astronomers, famously declared the idea of a beginning of time to be hateful. To him and many others, it felt uncomfortably close to philosophical or religious territory rather than pure physics. Their concern was simple, yet profound. If the universe truly had a beginning, science would be left facing a final, haunting question. What caused it? And so, beneath the quiet stars, humanity hesitated, listening, wondering, as the universe waited patiently to reveal its story. The whispers of motion, the idea of a static universe, began to fracture the moment careful observation revealed a quiet truth. The galaxies were not standing still. Vesto Slipher's footsteps and the Doppler effect. In 1912, astronomer Vesto Slipher began measuring the spectral signatures of what were then called spiral nebulae, objects we now know as distant galaxies. To his quiet astonishment, most of them appeared to be moving away from us. This motion revealed itself through a subtle shift in light. As an object recedes, its light stretches into longer wavelengths, growing slightly redder, a phenomenon known as redshift. Slipher was among the first to hear the faint, steady hum of a universe in motion. Yet at the time, the full meaning of what he had detected remained just beyond reach, like a distant melody carried on the night air. Edwin Hubble and the Distance Ladder. A few years later, Edwin Hubble provided the missing context. He demonstrated that these spiral nebulae were not small features within our Milky Way, but vast, independent island universes scattered across the cosmos. In 1929, Hubble uncovered a simple and profound relationship. The farther away a galaxy lies, the faster it is moving from us. This was the first clear evidence that the universe is expanding uniformly in all directions. Imagine dots painted on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot, and the ones farthest apart separate the fastest. Hubble's discovery not only expanded the known size of the universe, it invited a deeper question. If everything is moving apart now, then once, long ago, everything must have been much closer together. Georges Lemaitre and the primordial atom. While many scientists hesitated, the Belgian priest and physicist Georges Lemaitre followed this logic to its quiet conclusion. In 1931, he proposed that the expanding universe must have originated from an extremely dense and hot state, a single point he called the primordial atom, where space and time themselves were born. Lemaitre reasoned that if the universe emerged from such a beginning, then concepts like before would lose their meaning entirely. This idea formed the earliest outline of what we now call the Big Bang Theory, though at the time it was often dismissed as philosophical or theological speculation rather than physics, standing at the threshold of nothingness. When we push our equations backward toward the very first moments, we eventually arrive at a boundary, a place where familiar laws begin to dissolve. The singularity, where mathematics surrenders. According to general relativity, tracing the universe far enough into the past leads us to a singularity, a state of infinite density and temperature. Yet modern physics acknowledges a quiet limitation. We do not yet possess a complete theory of quantum gravity, one capable of describing such extremes. The singularity may not be a physical object at all, but rather a signal that our current understanding has reached its breaking point, a dark veil concealing whatever truly existed at the dawn of time. Speculations about the pre-Big Bang. Though this era cannot be observed directly, scientists have used mathematics to gently imagine what might lie beyond that veil. Quantum fluctuations. Some models suggest the universe emerged from apparent nothingness through spontaneous oscillations of vacuum energy. The emergent universe. In this view, the cosmos existed in a timeless, nearly motionless state for an eternity before being nudged into expansion, like a cosmic egg waiting patiently to awaken. The cyclic model, a poetic idea proposing that the Big Bang was not a beginning, but a rebound, a big bounce from a previous universe that had collapsed. In this vision, the cosmos breathes forever, expanding and contracting in endless rhythm. Eternal inflation. This theory suggests our universe is just one small bubble in a far larger space, where inflation never truly stops, giving rise to countless other universes beyond our view. Time, an emerging entity? Perhaps the most delicate question of all concerns time itself. Using tools such as the Wheeler-DeWitt equation, some physicists propose that time may not be fundamental. Instead, it could be an emergent property, arising only as the universe grows more complex. If this is true, then asking what came before the Big Bang may be meaningless, much like asking what lies north of the North Pole. At that boundary, the very concept dissolves. And so, at the edge of our understanding, we pause, listening to the silence, not as an absence, but as the quiet beginning of everything. Our journey through the dreams of the pre-Big Bang gently comes to rest here. You have witnessed humanity's quiet perseverance, how the human mind reaches toward the unreachable, striving to peer beyond singularities and to listen for the soft murmurs of nothingness itself. Now allow thoughts of expanding galaxies and fragile cosmic bubbles to slowly drift away. Rest in the simple assurance that, no matter how vast or mysterious the universe may be, tonight it surrounds you with calm and protection. You are part of this immense voyage, a small, luminous grain of stardust learning, patiently, to dream of its own beginnings. Let your body completely relax. Allow your eyelids to grow heavy. Drift into a deep, untroubled sleep, cradled by the silken arcs of the Milky Way. Night travelers, are you growing sleepy? I can hear your breathing now, slow, deep, unhurried. Draw the blanket a little closer. Let each breath dissolve into the quiet and feel your heartbeat ease into a gentle, steady rhythm. Our journey through time will continue. After resting within humanity's earliest dreams, we will step into a captivating new chapter, Whispers of the Dark. Here, elegant theories begin to meet careful observation. Darkness is no longer empty. It begins to speak softly through stretched bands of ancient light. Together, we will listen to voices from distant galaxies, silent evidence of a universe that has been breathing and expanding long before the name Big Bang was ever spoken. Whispers of the Dark, the stretched messengers of light. Tonight's story begins in 1912, at a time when most believed the universe to be calm, eternal, and unchanging. At a quiet observatory, far from the noise of the world, astronomer Vesto Slipher undertook a patient task, measuring the light from what were known then as spiral nebulae, faint smudges in the sky, not yet recognized as vast galaxies far beyond the Milky Way. What Slipher found was deeply unsettling. Most of these nebulae were moving away from Earth, and at remarkable speeds. To understand this, imagine light as a messenger carrying a musical tone. When the source is still, the note arrives clear and true. But when the source moves away, the sound stretches, softens, and lowers in pitch. With light, this stretching reveals itself as redshift. As a galaxy recedes, its light waves lengthen, gently sliding toward the red end of the spectrum. In these faint changes, Slipher heard a low, continuous murmur, the first whisper that the universe itself was not standing still. Though he did not yet grasp the full meaning of what he had uncovered, Slipher had taken the first quiet steps toward a profound realization. The cosmos is alive with motion, and even in its deepest darkness, it is always speaking. Edwin Hubble and the Measure of Infinity. If Vesto Slipher was the one who first heard the whisper, then Edwin Hubble was the man who finally learned how to read its meaning. In 1929, Hubble employed a remarkably refined method of measuring cosmic distances using variable stars, celestial lighthouses, whose brightness rises and falls with steady, reliable rhythm. Distant island universes. Before Hubble, humanity believed the Milky Way to be the whole of existence. But by carefully measuring the distance to the Andromeda Nebula, Hubble demonstrated that it lay millions of light years away, far beyond the boundaries of our own galaxy. In that quiet moment, the universe expanded beyond imagination, suddenly vast beyond measure, filled with countless island universes, each one a galaxy much like our own Milky Way. Hubble's law, the dance of distance. Hubble did not stop with distance alone. He placed galaxies onto a simple graph, comparing how far away they were with how fast they appeared to be moving. From this emerged a profound and elegant rule, later known as Hubble's law. The farther a galaxy lies from us, the faster it recedes. Imagine the universe as a great balloon, its surface dotted with tiny marks representing galaxies. As the balloon inflates, the space between the dots stretches, and every dot moves away from every other. Hubble realized that galaxies were not rushing through space. Rather, space itself was expanding between them. This insight offered the first solid evidence that the universe has a history, a motion, and perhaps a beginning. Lemaitre and the primitive atom. While Hubble was immersed in careful observation, a Belgian priest and physicist named Georges Lemaitre took a bold step into the realm of ideas. In 1931, he proposed a simple yet unsettling thought. If the universe is expanding today, then in the distant past, it must have been far smaller, far denser. The collapse of the distant past. Lemaitre envisioned a state he called the primeval atom, a moment when all the matter of the universe was compressed into a single, unimaginably hot and dense point. In that instant, space and time themselves were born, unfolding together from an initial cosmic seed. The resistance of old thinking. His proposal met fierce resistance. Even towering figures such as Albert Einstein and Arthur Eddington found the idea deeply uncomfortable. A universe with a beginning, they argued, felt uncomfortably close to philosophy or theology, challenging the long-held belief in an eternal, unchanging cosmos. Eddington famously called the notion of a beginning in time hateful. Yet despite the resistance, the quiet logic of Lemaitre's vision endured, laying the foundation for what would later be known as the Big Bang. Black holes, singularities in sight. Though the story of the Big Bang unfolds on the grandest scale imaginable, the whispers of darkness also arise from the universe's most extreme objects, black holes. Their story, too, began as a careful thought experiment, invisible stars. As early as the 18th century, Jean Michel and Pierre-Simon Laplace imagined stars whose gravity was so intense that even light could not escape. More than a century later, in 1916, amid the turmoil of the First World War, Carl Schwarzschild discovered the first exact solution to Einstein's equations, revealing a region where matter collapses so completely that space and time themselves are torn apart. The singularity and the limits of physics. At the heart of every black hole, theory predicts a singularity, a point where density becomes infinite and the known laws of physics quietly give up. In essence, the Big Bang itself began from a similar singularity, though on the scale of the entire universe. To study black holes, then, is to glimpse the conditions that once shaped the birth of everything. In 1971, the X-ray source Cygnus X1 became the first confirmed black hole candidate, transforming darkness from a mathematical curiosity into a physical reality. These silent giants teach us a profound lesson. In the universe, darkness is not emptiness. It is presence, deep, powerful, and filled with secrets about how space and time themselves can bend, stretch, and yield. The resilience of life in the void. One final whisper from the pre-Big Bang darkness speaks not of destruction, but of resilience, the quiet ability of matter to organize itself into something alive. Evidence suggests that the universe, from its earliest moments, was generous with the ingredients required for life. The Goldilocks era of the early universe. Roughly 15 million years after the beginning, as space expanded and cooled, the average temperature of the entire cosmos settled at around 24 degrees Celsius, gentle, familiar, like a calm spring afternoon. In that fleeting era, liquid water may have existed everywhere, without the need for warmth from stars that had not yet been born. This is a hopeful murmur in the dark. Life may not have been a late accident, but an intention quietly written into the universe's deepest structure, present from the opening lines of existence itself. The story of the Whispers of Darkness now draws to a close. You have heard how light stretches to reveal motion, how Edwin Hubble learned to measure infinity, and how Georges Lemaitre envisioned a primordial atom that once held everything we would become. Now allow yourself to rest in complete peace. You are lying on a small, fragile planet, wrapped in a gentle atmosphere, within a universe that has spent billions of years expanding and cooling, slowly, patiently, just to make room for your presence tonight. The mysteries of the past dissolve into the rhythm of your breathing. You are a single note in a vast cosmic symphony, a quiet grain of stardust learning, at last, how to return to its source. Let your body fully relax. Let your thoughts grow light. Drift into a sleep as wide and calm as the space beyond the stars. The universe is like an endless field of lights. Each faint red glow carries a seed of understanding. And tonight, all you need to do is remain still, allowing those seeds to unfold within the gentle landscape of your dreams. Are you still awake, my most patient night travelers? If so, sink a little deeper into this profound silence. Feel the warmth of the blanket around you. Listen to your heartbeat, soft, steady, moving in quiet harmony with the breath of the universe itself. We have traveled through humanity's ancient dreams and listened to the stretched whispers of distant galaxies. Now, our path brings us to the final boundary between knowledge and mystery. Welcome to the threshold of nothingness. This is the place where equations begin to lose their sharp edges, where time and space prepare for their first awakening. Together, we stand before an unseen wall, gazing toward a singularity both brilliant and dark, listening to careful speculations about what may have existed before beginning had meaning at all. Let your mind become as light as a drifting cloud, and as we gently touch the idea of nothingness, allow yourself to fall into the deepest, most peaceful sleep. Before the threshold of nothingness, the singularity, when mathematics surrenders. If we gently rewind the universe's story by 13.8 billion years, we do not arrive at a planet, a star, or even a drifting cloud of gas. Instead, everything that exists today, billions of galaxies, oceans of light, and the smallest grains of dust, collapses into a single state of unimaginable heat and density. The collapse of general relativity. According to Einstein's equations, traveling far enough back in time leads to a moment when the universe contracts into a point of infinite density and temperature. This moment is known as the singularity. Yet in physics, the appearance of the word infinity is not an answer. It is a warning. It tells us that our most trusted theories, so reliable for planets and galaxies, can no longer function here. At this extreme boundary, space and time themselves seem to tear apart, leaving us without language or tools to describe what is real. The knowledge gap, the Planck era. There is a silent boundary science has not yet crossed. Planck time, roughly 10 to the minus 43 seconds after the beginning. Any attempt to look earlier than this encounters overwhelming quantum effects. Gravity becomes unstable, and general relativity simply breaks down. Because we still lack a complete theory of quantum gravity, everything beyond this threshold remains hidden. We stand before a dark curtain, where the familiar laws of physics dissolve and certainty quietly fades. Time, a newly emerging entity? Perhaps the most haunting question of all is, what existed before the Big Bang? To ask it, however, we must face something even more fundamental, the nature of time itself. Is time eternal? Many of us imagine time as an endless river flowing smoothly from an infinite past toward an open future. Yet Georges Lemaitre, the architect of the primordial atom, suggested something far more unsettling. Space and time may have been born together with the universe. If existence began as a single quantum event, then space and time themselves would have had no meaning at that instant. In this view, the universe may have begun just slightly before time itself had any definition. The Wheeler-DeWitt equation and the vanishing of time. In the effort to unite quantum mechanics with cosmology, physicists developed the Wheeler-DeWitt equation, an equation meant to describe the entire universe. Strangely, time does not appear in it at all. This absence suggests that time may not be a fundamental feature of reality. Instead, it may be an emergent property, much like temperature arises from the collective motion of molecules. If this is true, then time did not exist before the Great Beginning. Asking what happened before the Big Bang becomes like asking, which direction is north of the North Pole? A question without meaning, because the concept itself does not exist there. Sketches of the pre-beginning. Though we cannot see beyond the singularity, mathematics and imagination allow us to sketch quiet possibilities of what may have preceded our universe. Quantum fluctuations. Some of the simplest models propose that the universe emerged from random quantum fluctuations in a vacuum. In the quantum world, energy may briefly arise from nothing and vanish again. Given infinite time, or the absence of time itself, an extraordinarily rare fluctuation could occur, large enough to give birth to an entire universe. In this view, existence itself may be the ultimate free gift, quietly blooming from nothingness. The emergent universe. Another vision describes an eternity of stillness before expansion ever began. The universe rests like a cosmic egg, suspended in perfect calm within the darkness of primordial chaos, waiting, patiently, silently, for a subtle trigger to awaken and begin its long journey into space. The cyclical model and the big bounce. This is a poetic and ancient idea, first explored by Albert Einstein in 1930. Rather than having an absolute beginning, the universe may move through endless cycles of expansion and contraction. In this view, what we call our beginning is actually the echo of a previous ending, a big crunch from an earlier universe. When an old universe collapses under its own gravity, it does not vanish into oblivion. Instead, it rebounds, giving rise to a new burst of creation. The universe, in this sense, resembles a living, breathing presence, each slow breath stretching across tens of billions of years. Eternal inflation and bubble universes. Another quiet possibility emerges from the theory of eternal inflation. Here, the rapid expansion of space never truly ends on the largest scale. It continues endlessly, like a vast and restless cosmic ocean. Our universe may be nothing more than a small bubble that gently separated from this inflating sea, beginning its own local history. If this picture is true, then countless other universes may exist, each with its own physical laws, floating silently within a larger primordial expanse beyond our perception. Lessons from black holes. To understand the universe's beginning, scientists often turn to a remarkable natural laboratory: black holes. Parallels between black holes and the Big Bang. Both black holes and the early universe involve singularities, regions where matter is compressed to extreme limits. By studying black holes, we are able to observe such conditions from the outside, where gravity's effects can be examined without being completely overwhelming. In this way, a black hole can be seen as a universe collapsing inward, a kind of reverse Big Bang, a big crunch in miniature. The information paradox and the preservation of the past. Stephen Hawking once raised a troubling question. If a black hole evaporates and disappears, what happens to the information about everything that fell into it? If that information is lost, the foundations of quantum physics would be broken. Recent advances involving the concept of islands and the page curve suggest a gentler answer. Information may not be destroyed at all, but subtly encoded and released through Hawking radiation. This insight carries profound implications for the origin of the universe. It hints that information from before the Big Bang may not have been erased, but quietly preserved within the deep structure of space-time itself. The silence of nothingness and the meaning of existence. We find ourselves here at the quiet edge of understanding, gazing toward the blank wall and reflecting on our place within it all. Is the universe self-sufficient? According to the Hartley-Hawking no-boundary proposal, the universe may require no external cause and no single moment of creation in a linear sense. It may be complete unto itself. Like the surface of a sphere, one can travel endlessly without ever encountering a true beginning or a final edge. Why something instead of nothing? This is the deepest question to emerge from the threshold of nothingness. If the universe is flat, then the negative energy of gravity could perfectly cancel the positive energy of matter. The total energy of the universe would be zero. In that delicate balance, existence itself becomes possible without violating any physical law, a quiet equilibrium between being and non-being, where the universe arises not in defiance of nothingness, but in perfect harmony with it. The story of the threshold of nothingness comes gently to a close here. You have seen how darkness and light, destruction and creation quietly intertwine to form the very foundation of our existence. You have followed humanity's patient perseverance, its long effort to peer beyond the Planck wall and glimpse the origins of all things. Now allow thoughts of singularities and eternal cycles to slowly fade. Rest in the quiet certainty that you are part of this vast journey, a single note in an eternal symphony written into the source code of matter billions of years ago. The atoms within your body were once part of that primordial state, and tonight they rest safely within the calm embrace of the night. Completely relax your body, let your eyelids grow heavy, and allow your mind to drift into the tranquil ocean of nothingness. Night travelers, once more, release all tension. Let the pillow gently support your head. Let your breathing fall into a steady rhythm, harmonizing with the deep stillness of space. We have journeyed through three great movements of a cosmic epic: the silent dreams of humanity, the whispers of darkness, and the threshold of nothingness itself. Now, allow me to gather these threads into a final, gentle reflection on the universe before the Big Bang. This is the story of a time when time had not yet learned to flow, and space itself remained an unanswered question. Close your eyes and let your thoughts drift softly toward the edge of nothingness, the last resistance of a still universe. Before evidence of a beginning emerged, humanity lived for millennia with the comforting belief that the universe was eternal and unmoving. Even minds as great as Albert Einstein initially resisted the notion that the universe might have a birthday. To early 20th century scientists, the idea of a beginning carried unsettling religious and philosophical echoes. Arthur Eddington famously described such a concept as repugnant. It felt safer to imagine matter as everlasting than to confront creation arising from nothing. Yet doubt had been quietly forming long before. As early as the 18th century, Reverend John Michel in 1784, and later Pierre-Simon Laplace in 1795, independently imagined the existence of dark stars, objects so dense that their gravity could imprison even light. These ideas were purely theoretical at the time, but they planted an important seed. Space itself could be bent to extreme limits, hinting at a super-dense state the universe may once have known. Whispers from expansion. The long silence of the universe began to break when distant light finally spoke. In 1912, astronomer Vesto Slipher discovered a subtle but profound effect. The light from spiral nebulae was stretched toward the red end of the spectrum. This redshift revealed that these distant objects were moving away from us at extraordinary speeds. By 1929, Edwin Hubble transformed this quiet whisper into a clear and universal law. The farther away a galaxy lies, the faster it recedes. Space itself, he showed, is not still. It is expanding, continuously and everywhere. When we rewind this expansion in our minds, logic leads us to a single, unavoidable conclusion. All matter, all energy, all space must once have been gathered together. From this realization, Georges Lemaitre took a bold step in 1931. He proposed the idea of the primeval atom, a single, intensely hot and dense quantum from which space and time themselves were born. With this thought, humanity arrived at the threshold of what we now call the pre-Big Bang, the quiet edge where understanding pauses and wonder begins. Standing at the threshold of nothingness, the singularity. As scientists use mathematics to peer ever deeper into the past, they eventually reach an invisible boundary known as the singularity. When we trace the universe back to 13.8 billion years ago, the general theory of relativity predicts that density and temperature rise without limit. Yet in physics, the word infinite is not an answer. It is a warning. It marks the point where our familiar laws quietly lay down their tools. There exists a final temporal frontier known as Planck time, roughly 10 to the minus 43 seconds after the beginning. Beyond this threshold, the influence of quantum gravity overwhelms Einstein's equations, rendering them unusable. We find ourselves standing before a dark, impenetrable screen, a place where the known laws of physics dissolve into silence. Perhaps the most unsettling question at this edge concerns the nature of time itself. Some physicists, working with the Wheeler-DeWitt equation, suggest that time may not be fundamental at all. It may be an emergent quality, something that appeared only as the universe grew in structure and complexity. If this is true, then the notion of before the Big Bang has no meaning, much like trying to travel north of the North Pole. The direction itself simply does not exist there. Sketches of the pre-beginning, cosmogony. Although no light can pass through the singularity, human imagination, guided by mathematics, has traced several quiet and compelling possibilities for what may have preceded the Great Bang. The universe from nothing. One hypothesis proposes that the universe arose from random quantum fluctuations in a vacuum. In this view, existence is a kind of cosmic free lunch, where negative gravitational energy perfectly balances the positive energy of matter, leaving the total energy of the universe at zero. The emergent universe. This scenario envisions an infinitely long, tranquil era before expansion began, a cosmic egg resting peacefully in primordial darkness, waiting for a subtle trigger to awaken and unfold. The cyclic model and the Big Bounce. First suggested by Einstein in 1930, this poetic idea imagines the universe as a breathing entity. Expansion follows contraction, and each Big Bang is not a true beginning, but the rebound of a prior universe collapsing in a big crunch. Perpetual inflation and the multiverse. According to this theory, rapid inflation never truly ends on the largest scale. Our universe is merely one small bubble that's separated from an ongoing process, carrying with it its own unique set of physical laws, drifting within a far larger cosmic sea. The legacy of information in the dark. One of the most profound insights into beginnings comes from the study of black holes, the universe's smallest laboratories of singularity-like conditions. Stephen Hawking and later physicists revealed something quietly reassuring. Information is never truly lost. Through the Page curve and the concept of quantum islands, we now understand that the information of matter consumed by black holes is subtly encoded and released through Hawking radiation. This discovery carries deep implications for cosmology. It suggests that information from the universe's earliest moments, even from the pre-Big Bang era, may not have vanished at all. Instead, it may still be woven, delicately and patiently, into the fabric of space-time we inhabit today. Your breath now slows, deep and unhurried. Feel the quiet reassurance of being held within a universe that has spent billions of years preparing for your presence tonight. Whether it began with a sudden leap, a gentle quantum fluctuation, or a breath within an endless cycle, every atom in your body carries the memory of that first moment of becoming. The universe beyond you, vast, ancient, and filled with mystery, is also wrapping you in the stillness of the night. You are part of this great symphony, a small trace of stardust, slowly learning to dream of where it came from. Allow your body to fully relax. Let your eyelids grow heavy. Drift into a peaceful sleep, cradled by the soft silks of the Milky Way. Are you still with me, night travelers? Gently adjust your pillow. Let your shoulders soften completely and feel the warmth of the blanket resting upon you. Take a slow, deep breath. Notice the lightness it brings, and exhale just as slowly, as though you are floating into a calm, dark ocean. Tonight, we open a different kind of book. We leave behind the noise of daily life and turn together to the very first chapter of the greatest story ever told, Echoes from the Beginning. This chapter speaks of a time when the phrase Big Bang was nothing more than an offhand remark, when the universe existed only as equations in the minds of quiet thinkers, and when humanity slowly realized that the heavens were not as still as they once appeared. Let your thoughts become light and allow this story to guide you gently toward rest. Echoes from the Earth, the Big Bang, an unintentional name. Our story begins not with thunder or fire, but with a curious twist of language. The name Big Bang, now spoken across the world, was never meant to be celebrated. It was born instead from irony. In March of 1949, during a BBC radio broadcast, British astronomer Fred Hoyle used the phrase, "this Big Bang idea." Hoyle was a devoted supporter of the steady-state model, a vision of an eternal universe, unchanging and without a beginning. To him, Georges Lemaitre's proposal of a sudden cosmic origin seemed unnecessary, even absurd. The phrase was meant to draw a sharp contrast, a vivid image for radio listeners, not a compliment. Yet irony has its own sense of timing. The image was so striking, so easy to remember, that it endured. What began as a casual remark became the name we now associate with the birth of everything. There is, however, one important clarification that brings a sense of calm. The term Big Bang easily misleads us. When we hear the word explosion, we imagine something bursting outward into empty space, scattering fragments into a waiting void. But the Big Bang was nothing like that. It was not an explosion in space. It was the expansion of space itself. Imagine the universe as a vast rubber balloon, slowly being inflated. The galaxies are not racing away from one another across a fixed stage. Instead, the space between them is stretching, gently and relentlessly, carrying everything farther apart. Because the universe contains all space, it is not expanding into anything beyond itself. It is simply growing from within. At that earliest moment, some 13.8 billion years ago, all the mass and energy of every galaxy we see today were compressed into a region smaller than a coin. The universe existed in a state of unimaginable heat and density, so extreme that even the familiar laws of physics quietly yielded before it. And from that silent intensity, everything we know began its long, unfolding journey. The architects of the idea, long before modern telescopes could pierce the darkness of deep space, the idea of the Big Bang existed only as fragile seeds in the minds of a few courageous thinkers. Armed with nothing more than mathematics and patience, they dared to sketch a reality that even Albert Einstein himself had once resisted. In 1922, the first foundation stones were laid by the Russian mathematician Alexander Friedmann. By carefully solving the demanding equations of general relativity, Friedmann arrived at a startling conclusion. The universe could not be eternally still. It must either be expanding or contracting. This insight quietly but firmly challenged a belief that had endured for thousands of years, the notion of a static, unchanging sky. Yet it was the Belgian priest and physicist Georges Lemaitre who truly gave this idea a living form. Working independently of Friedman, Lemaitre proposed in 1927 that the motion of distant nebulae was not random, but a sign that the universe itself was expanding. 4 years later, in 1931, he took an even bolder step, introducing the concept of the primeval atom. Lemaitre invited us to imagine rewinding the film of cosmic time. As the universe runs backward, it grows smaller, denser, and hotter, until, at some unimaginable moment, all matter converges into a single point, a primordial quantum, a place where space and time themselves first came into being. With quiet poetry, Lemaitre wrote, "The beginning of the world happened a little before space and time existed." Unsurprisingly, the idea of a cosmic birthday met with deep resistance. Arthur Eddington, one of the most respected astronomers of his era, famously described the notion of a beginning of time as repugnant. To many scientists, it seemed to invite religious or philosophical ideas into a discipline that sought pure objectivity. Even Einstein attempted to preserve a motionless universe by introducing the cosmological constant into his equations, an addition he would later call the greatest mistake of his life. Sometimes, truth does not arrive loudly. It waits, patiently, for human prejudice to soften. When darkness whispers. The final collapse of static theories did not come through arguments or lectures, but through faint, almost imperceptible whispers of light from distant galaxies. Observation, not opinion, became the firm pillar upon which the Big Bang would stand. The first whisper was heard in 1912 through the quiet and meticulous work of Vesto Slipher. From his observatory, Slipher studied the light of what were then called spiral nebulae, objects we now recognize as entire galaxies. What he found was unsettling. Most of them were rushing away from us at extraordinary speeds. Their light was shifted toward the red end of the spectrum, a phenomenon now known as redshift. The effect is familiar, even comforting, in everyday life. Think of an ambulance passing by in the night. As it approaches, the siren sounds sharp and high. As it moves away, the sound deepens and fades. Light behaves in much the same way. When a galaxy recedes, its light waves stretch, losing energy, appearing redder to our eyes. Slipher heard the low, distant murmur of an expanding universe, but it was Edwin Hubble who finally translated that murmur into a clear and undeniable message. In 1929, Hubble carefully measured the distances to galaxies and compared them with their velocities. What emerged was a simple and profound rule. The farther away a galaxy is, the faster it is moving from us. This relationship revealed that the universe is not frozen in place. It is alive, expanding evenly in all directions, like a slow and steady breath. Hubble's discovery did more than enlarge our picture of the cosmos by billions of times. It also allowed humanity, for the first time, to estimate the age of the universe itself. Early calculations were flawed. Hubble initially suggested an age of just 2 billion years, a figure that troubled geologists, who already knew the Earth was far older. But with decades of improved measurements and technology, the picture gradually sharpened. Today, we rest with quiet confidence in a universe that is approximately 13.787 plus or minus 0.02 billion years old, ancient, vast, and still unfolding its story in the darkness above us. And tonight, as you listen, you are part of that story too. Your breath is now slow, gentle, steady. Feel the quiet reassurance that everything we see today, from the distant brilliance of the stars to the simple warmth filling this room, shares a single origin. You are not alone in this vastness. You are part of a great symphony that began 13.8 billion years ago and still resonates softly tonight. The mysteries of the past are settling into the rhythm of your heartbeat. Completely relax your body. Let your thoughts grow lighter. Drift toward a peaceful sleep, as wide and unhurried as the space beyond the window. Adjust your position once more. Let the pillow gently support your neck. Let the blanket rest comfortably along your legs. Release the tension in your shoulders. Take a slow, deep breath. Feel your chest rise calmly, and then exhale, unhurried, as though you are laying down every remaining weight of the day, allowing yourself to drift into the steady flow of eternal time. Tonight, after sharing the quiet dreams of humanity, we arrive at the most important chapter of our journey, where speculation begins to step aside and evidence speaks with a clear and steady voice. Welcome to the Pillars of Truth, actual evidence. This is the story of how the universe reveals its own history. Through stretched rays of light, faint echoes of ancient temperatures, and glowing cauldrons of primordial matter. Let your mind be light, like drifting stardust, and listen closely to the voice of space itself. Pillars of Truth, the dance of moving galaxies. The first firm evidence does not begin in a laboratory, but atop quiet, windswept observatories. At the dawn of the 20th century, astronomer Edwin Hubble made a profound realization. The night sky is not frozen in time. The distance ladder and island universes. Before Hubble, many believed the Milky Way was the entirety of existence. Using precise distance measurements based on Cepheid variable stars, Hubble demonstrated that the faint smudges once called nebulae were, in fact, independent galaxies, vast island universes located millions of light years away. In a single moment, humanity's cosmic home became astonishingly small, set within a universe billions of times larger than previously imagined. The redshift effect. As Hubble examined the light from these distant galaxies, he noticed a subtle but decisive pattern. Their light appeared stretched, shifted toward the red end of the spectrum. The effect is familiar. When an ambulance passes and moves away, its siren drops in pitch because the sound waves are stretched. Light behaves in much the same way. As galaxies recede, their light lengthens, reddens, and quietly announces their retreat. This redshift is the galaxy's calm confession. They are moving away from us, swiftly and relentlessly. Hubble's law and the cosmic balloon. In 1929, Hubble uncovered a simple and powerful rule. The farther a galaxy lies from us, the faster it is moving away. This relationship stands as the strongest evidence that the universe is expanding evenly in all directions. Imagine a balloon marked with dots across its surface. As the balloon inflates, every dot moves farther from the others. The most distant dots separate the fastest. Yet there is an important difference. The balloon expands into the surrounding air, while the universe expands into nothing at all. It is space itself, between galaxies, that is stretching. If we gently rewind this cosmic motion, reason leads us to a single, unavoidable conclusion. There was a time when everything, space, matter, and energy, was gathered together at one brilliant, blazing point. And in the stillness of this night, that ancient moment continues to echo, softly, patiently, waiting for you to rest. The thermal echoes from the dawn. If Hubble's expansion is the body of the evidence, then the cosmic microwave background, or CMB, is its quiet and enduring soul. It is the gentle proof that the universe was once a single, immense furnace, glowing everywhere at once. The strange noise at Holmdel. In 1964, two engineers, Arno Penzias and Robert Wilson, were working at the Holmdel Horn Antenna in New Jersey. Their task was practical and mundane, eliminate unwanted interference. Yet they were troubled by a faint, persistent murmur, an unyielding hiss that came from every direction in the sky, day and night. They tested every explanation they could imagine. They recalibrated equipment. They ruled out atmospheric effects. They even removed bird droppings from the antenna itself. Still, the sound remained. What they were hearing was not noise at all. It was ancient heat, thermal radiation left behind from the birth of the universe itself. The first light to escape its shell. Roughly 380,000 years after the Big Bang, the universe cooled to about 3,000 degrees Celsius. At that moment, electrons finally slowed enough to bind with atomic nuclei, forming the first stable atoms. This pivotal event is known as recombination. Before it, the universe was wrapped in a dense, glowing fog, opaque to light. Photons could not travel freely. But as atoms formed, the fog lifted. Space became transparent. Light, long imprisoned, was finally released to wander the cosmos. That first light is still with us. The map of life, WMAP and Planck. Over the course of 13.8 billion years, that brilliant glow stretched and cooled, fading into microwaves with a temperature of just 2.725 Kelvin, barely above absolute zero. Satellites such as COBE, WMAP, and Planck have mapped this radiation with exquisite precision. They revealed tiny variations in temperature, differences as small as 1 part in 100,000. These faint blue and red patches are not imperfections. They are the universe's earliest fingerprints. Where matter was ever so slightly denser, gravity began its quiet work, drawing material together. From these subtle irregularities, galaxies, stars, and ultimately worlds were born. The recipe of creation. The third pillar of evidence lies much closer than distant galaxies. It is written inside every atom of your body and in every star overhead. It is the precise abundance of the universe's earliest elements, a blazing nuclear soup. In the first few minutes after the beginning, the universe was unimaginably hot and dense, behaving like a colossal nuclear reactor. Physicists call this phase Big Bang nucleosynthesis. During this brief window, the universe forged its first elements, primarily hydrogen and helium. From the laws of physics alone, scientists calculated exactly how much of each should have formed. The golden ratio of matter. When we measure the universe today, we find that ordinary matter consists of roughly 75% hydrogen and 25% helium by mass. This balance matches the predictions of the Big Bang with remarkable precision. No other theory, not even the nuclear fires within stars, can explain why so much helium exists across the cosmos. The lithium problem and primordial clouds. There remains a quiet puzzle. The observed amount of lithium-7 is lower than predicted, a discrepancy known as the cosmic lithium problem. Yet this does not weaken the larger picture. In 2011, astronomers discovered ancient gas clouds dating back billions of years. These clouds contain no heavy elements at all. No carbon, no oxygen, nothing forged by stars. They are chemically pristine, untouched, since the universe's earliest moments. Their existence confirms that the Big Bang laid down the first chemical blueprint of reality, a foundation upon which everything else would slowly, patiently grow. And as you rest here tonight, breathing calmly in the dark, those same ancient processes still echo quietly through the atoms that make you who you are. Galactic fossils and evolution. The most compelling evidence of all comes from a simple truth. Light takes time to travel. Because of this, every telescope is a quiet time machine, allowing us to look backward into the universe's long memory, observing it as it once was. Young and old galaxies. When astronomers study galaxies at immense distances, billions of light years away, they are, in fact, witnessing the universe in its youth. These distant galaxies appear small, irregular, and restless, crowded with young, brilliant stars burning intensely. Closer to home, the story is very different. Nearby galaxies, including our own Milky Way, display calm, mature forms, graceful spirals or smooth ellipticals, populated by countless old stars that have been shining for billions of years. This contrast is not subtle, it is unmistakable, the collapse of the steady-state dream. Such an orderly progression delivers a decisive blow to theories that once claimed the universe was eternal and unchanging. If the cosmos had no beginning, we would expect to see young and old galaxies scattered randomly at every distance. Instead, we see growth, aging, and structure unfolding over time. The universe has a history. It has known youth, transformation, and gradual maturity, an unmistakable signature of an explosive beginning followed by a long, patient evolution. The imprint of inflation. Gravitational whispers. In March 2014, scientists working in the frozen silence of Antarctica announced the detection of faint patterns imprinted on the cosmic microwave background, subtle traces believed to be primordial gravitational waves. These ripples are thought to originate from inflation, a fleeting moment when the universe expanded at an astonishing rate, far faster than light itself, in the earliest fraction of a second after the Big Bang. Although this evidence continues to be carefully examined and debated, it offers a tantalizing glimpse of the universe's most violent and transformative moment, etched delicately into the oldest light we can observe. You have now seen how light and matter conspired to leave enduring fingerprints on the fabric of history. So let a deep calm settle over you. You are resting on a living planet, wrapped gently within a solar system sheltered by the heliosphere. Far from the galactic center, some 26,000 light-years away, you lie within one of nature's safest havens. The furious heat and violent motion of the early universe have long since faded, giving way to the quiet warmth that surrounds you tonight. I imagine you now, curled beneath a familiar blanket. Let your breath soften into stillness. Let your heartbeat slow, steady, and calm. Together, we have traveled through the fiery dawn of the Big Bang and examined the solid pillars of evidence that support it. Now, as your thoughts begin to loosen their grip, we approach the final chapter, the realm of unanswered questions and distant horizons. Welcome to Mysteries Amidst Infinity, Controversy, and the Future. Here, the cosmic symphony grows quieter, tinged with uncertainty. Here, scientists continue their late-night debates, and we gaze toward the far sunset of time, asking softly, how will it all end? Relax completely, close your eyes, and allow these mysteries to guide you gently into rest. The inflation storm and perfect wrinkles. Although the Big Bang explains much, it leaves behind a subtle unease, a lingering ripple that continues to trouble physicists. This is known as the horizon and flatness problem. Imagine looking at two opposite ends of the sky. These regions are separated by billions of light years and, according to ordinary physics, could never have exchanged information. Yet their temperatures are nearly identical, matching to within 1,000th of a degree. How could such distant regions share the same conditions if they had never met? To resolve this quiet contradiction, in 1981, physicist Alan Guth proposed the theory of inflation. He suggested that in an unimaginably brief instant, around 10 to the minus 37 seconds after the beginning, the universe underwent a phase of extraordinarily rapid expansion. A tiny region ballooned into an immense cosmos almost instantly, smoothing out irregularities and equalizing temperatures before space itself stretched too far apart. Inflation, in this view, flattened the universe's wrinkles and set the stage for everything that followed. Yet even this elegant solution remains a subject of deep debate. While observations from the WMAP and Planck satellites confirm many of inflation's predictions, some scientists, including pioneers of the theory itself, now express doubt. They ask whether inflation truly occurred, or whether it serves as a mathematical veil, concealing a deeper and more complex truth that still lies beyond our understanding. And with that unanswered question gently hanging in the darkness, you are free to rest, floating quietly at the edge of what we know and what we have yet to discover. The ghosts that dominate the universe. If you were to unfold a map of the universe as it exists today, you would be met with a sobering truth. Everything we can touch, see, or measure, from the distant brilliance of stars to the quiet warmth of your own body, accounts for less than 5% of all that exists. The remaining 95% belongs to two vast and elusive presences, dark matter and dark energy. Dark matter, the invisible backbone. In the 1970s, astronomers began to notice something deeply unsettling. Galaxies were spinning far too quickly. Based on the amount of visible matter they contained, they should have torn themselves apart, flinging stars into the void. Yet they remained intact. There had to be something unseen, something that neither emits nor reflects light, something that passes silently through space while exerting a powerful gravitational grip. This unseen scaffold is what we now call dark matter. It makes up roughly 26 to 27% of the universe, forming the hidden framework upon which galaxies are built. These particles are like silent guardians, shaping cosmic structures without ever revealing themselves. And despite decades of effort, no experiment on Earth has yet captured a single dark matter particle directly. Dark energy, the relentless push. Even more mysterious is dark energy, which dominates the universe at nearly 70%. For most of the 20th century, scientists believed gravity would gradually slow the cosmic expansion. But in the late 1990s, careful observations revealed a startling reversal. The universe is not slowing down, it is accelerating. Some unknown influence is woven into the very fabric of empty space, gently but relentlessly pushing galaxies away from one another, faster and faster with time. Recent observations from projects such as the Dark Energy Survey and DESI suggest something even more unsettling. Dark energy may not be a fixed constant, as Einstein once assumed. It may be evolving. Some physicists have proposed that a subtle particle, perhaps an axion, could be driving this expansion. If dark energy truly changes over time, then the future of the universe may unfold in ways far stranger than any story we have yet imagined. The loss of half the world. Baryon asymmetry. There is a quiet question that invites humility and gratitude whenever we consider it. Why does anything exist at all? According to the Big Bang model, the earliest moments of the universe produced matter and antimatter in nearly perfect balance. When matter meets antimatter, both vanish in a flash of light. Had this symmetry been exact, the universe would now be a vast, empty sea of radiation. No atoms, no planets, no life. And yet, here we are. Somehow, by a tiny margin, perhaps one extra particle of matter for every billion pairs, a small excess survived the Great Annihilation. From that fragile imbalance arose galaxies, stars, worlds, and eventually consciousness itself. Why nature favored matter over antimatter remains one of the deepest unsolved puzzles in physics, a subtle crack in the symmetry of the equations, still waiting to be understood. Black holes that defy time. When the James Webb Space Telescope turned its gaze toward the early universe, it revealed something profoundly unexpected. Astronomers discovered supermassive black holes, billions of times the mass of our sun, already fully formed just 500 to 600 million years after the Big Bang. One striking example is the galaxy Canix LRDZ 8.6, home to a black hole growing at a pace far exceeding that of its surrounding galaxy. This raises a troubling question. How could such immense objects have formed so quickly if they began only as the remnants of the first stars? These observations suggest that the early universe may have allowed black holes to form through direct collapse, bypassing the usual stellar stages. Others speculate that primordial black hole seeds may have existed almost from the beginning itself. Each faint little red dot discovered by Webb is a quiet reminder that our earliest chapters of cosmic history may need to be rewritten. And so, as you rest here in the calm of the night, remember this. Much of the universe remains unseen, unheard, and unresolved. Yet it is precisely these silent mysteries, the ghosts of matter, the push of dark energy, the impossible speed of ancient black holes, that continue to guide us forward, gently reminding us how much there still is to discover. The dance of destiny. Where is the universe heading? Now, let your breath slow and gently turn your thoughts toward the distant future, where galaxies begin their final silent dance. Our Milky Way is not alone in the dark. Far ahead of us, our great neighbor Andromeda is moving closer at more than 320,000 kilometers per hour. In about 4 to 5 billion years, these two vast galaxies will begin a majestic encounter. The stars themselves will not collide. The distances between them are far too great, but gravity will patiently unravel both structures. Spiral arms will stretch and twist, and our own solar system will be carried into a new orbit within a merged galaxy, often called Milkomeda. At the heart of this transformation, two supermassive black holes, Sagittarius, a star, and the central black hole of Andromeda, will circle one another in a slow, fatal embrace. As they spiral inward, they will release powerful gravitational waves, ripples that shake the fabric of space-time itself, before finally becoming one. Yet this is only a local chapter. The ultimate fate of the universe depends on a far greater contest, the quiet struggle between gravity and dark energy. The Big Freeze, eternal sleep. This is the scenario most favored by scientists today. The universe will continue to expand without end. Stars will exhaust their fuel and fade one by one. Galaxies will grow dark. The cosmos will enter the long black hole age, where black holes are the final structures to remain. Over unimaginable spans of time, around 10 to the 100th power years, even black holes will slowly evaporate through Hawking radiation. What remains will be a universe of near-perfect stillness. No heat, no motion, no structure, an endless, silent sleep. The Big Rip, the Great Tearing. If dark energy grows stronger with time, the expansion of the universe will become violent. First, galaxy clusters will be torn apart, then stars, planets, and eventually even atoms themselves. In the final moments, space-time would unravel, leaving nothing intact. Big crunch and big bounce, rebirth. If gravity were somehow to regain control, expansion would slow and reverse. The universe would collapse inward, drawn back into a fiery big crunch. But instead of vanishing forever, it might rebound, giving rise to a new Big Bang. In this poetic vision, the universe breathes in cycles, where every ending quietly prepares the ground for a new beginning. Our final chapter on the mysteries of infinity draws to a close here. You have seen how the universe, even through destruction and darkness, preserves meaning through fragile threads of information. Now, let thoughts of evaporating black holes and distant galaxies drift away. Feel the deep calm of knowing that, whatever the future holds, you are an essential note in this vast symphony. The atoms within you were present at the beginning, and one day they will carry the memory of your existence into eternity. Based on all 3 chapters we have traveled together, allow me to offer a final, gentle summary, a quiet symphony of light, matter, and unanswered questions. Let your mind grow light, like a single grain of stardust, and listen. Our universe, according to the most precise measurements we possess, began about 13.8 billion years ago. And yet, the name Big Bang itself is a small irony of history. In 1949, astronomer Fred Hoyle, an advocate of an eternal, unchanging universe, used the phrase during a BBC broadcast to gently mock the idea of a sudden beginning. He referred to it as this Big Bang idea. The image, however, proved unforgettable, and it remained. In truth, the Big Bang was not an explosion in space, like a firework in an empty room. It was the expansion of space itself. Picture the universe as a rubber balloon being inflated. Galaxies are not racing through space, but are carried apart as the space between them steadily grows. Long before telescopes could confirm this vision, mathematicians such as Alexander Friedmann in 1922 and Georges Lemaitre in 1927 followed Einstein's equations to their quiet conclusion: the universe could not remain still. Lemaitre imagined a primordial atom, a tiny, unimaginably hot and dense seed, holding all the energy and matter that would one day become everything we see. And tonight, as you rest in the gentle silence, you are still part of that unfolding story, born from its beginning, carried by its present, and softly woven into its infinite future. The universe is not merely an object of speculation. It has patiently told its own story through clear, undeniable evidence, written in light and time. The narrative of light. In 1924, Edwin Hubble revealed a profound truth. The Milky Way is not the entire universe. Beyond it lie countless other galaxies. 5 years later, in 1929, he uncovered a simple yet powerful rule that would forever change our understanding of the cosmos. The farther a galaxy is from us, the faster it is moving away. The light from these distant galaxies is stretched as it travels through expanding space, shifting toward the red end of the spectrum, a phenomenon known as redshift. This gentle reddening of ancient light is a quiet but persistent message, telling us that the universe is expanding moment by moment, even now. Echoes from the dawn. In 1964, two engineers, Arno Penzias and Robert Wilson, were troubled by a faint, stubborn noise detected by their antenna in New Jersey. They tried everything to remove it, unaware that they were listening to one of the universe's oldest whispers. That signal turned out to be the cosmic microwave background radiation, the first light released when the universe cooled enough to become transparent, about 380,000 years after the Big Bang. Today, it remains as a uniform, faint warmth at just 2.725 Kelvin, the dying embers of a primordial fire that once filled all of space. The recipe of creation. The Big Bang Theory predicted that in the universe's first few minutes, a simple atomic soup would form, producing hydrogen and helium in very specific proportions. When astronomers measured the cosmos, they found exactly that: about 75% hydrogen and 25% helium. The universe had followed the recipe written in its earliest moments with remarkable precision. Yet even with all this understanding, the Big Bang leaves behind lingering notes of mystery and quiet unease. The inflation storm. To explain why the universe appears so smooth and balanced, physicist Alan Guth proposed the theory of inflation in 1981. He suggested that, in a fraction of a trillionth of a second after the beginning, the universe expanded faster than light itself, stretching space-time, smoothing its wrinkles, and setting the stage for everything that followed. Powerful ghosts. We have also learned a humbling truth. Everything we can see, stars, planets, even ourselves, makes up less than 5% of the universe. The remaining 95% belongs to unseen forces. Dark matter acts as a hidden scaffold, holding galaxies together. Dark energy, even more mysterious, pushes space itself to expand faster and faster. These invisible presences shape the universe, silently guiding its fate. The singularity. When we trace the universe back to its earliest instant, we encounter a boundary, a point where density and temperature become infinite, and all known laws of physics break down. At this threshold, scientists still ask whether the idea of before has any meaning at all. if time itself was born alongside the universe? And how will this great journey one day conclude? Science offers several contemplative possibilities. Heat death. The universe may continue expanding forever. Stars will fade, energy will be spent, and all motion will gradually cease, leaving a cosmos of endless stillness. The Big Rip. If dark energy grows stronger, it may eventually overpower every force, tearing apart galaxies, stars, planets, and even the atoms themselves. The Big Bounce. A more poetic vision suggests that the universe may be cyclical, collapsing into a great contraction, only to rebound into a new beginning, an eternal rhythm of endings and rebirths. Your breath is now slow and deep. Rest in the quiet certainty that, however vast and mysterious the universe may be, it holds you gently within the calm of this night. You are part of this immense journey. The atoms in your body were once part of that primordial beginning, carrying within them the memory of light from 13.8 billion years ago. Relax completely. Let your eyelids grow heavy and drift softly into the gentle darkness of the Milky Way. Now adjust your pillows until you feel perfectly at ease. Let your shoulders sink, your muscles soften, and notice the quiet warmth of the blanket resting against your feet. Take a slow, deep breath. Feel the mind grow lighter, and exhale gently, as though gravity itself has loosened its hold, allowing you to drift into a vast, silent ocean of darkness. Tonight, we will leave behind the noise of everyday life. Together, we will open one of the most wondrous chapters in the book of the cosmos, when light cried its birth. This is the story of a journey, from a blazing seed of existence to the moment when the first majestic structures of the universe began to take shape. Let your thoughts become weightless and allow the quiet symphony of space to guide you toward a deep and peaceful sleep. When light cried its birth, the formation of structure, the seed, and the great leap. Our story begins at an almost unimaginable moment, 13.8 billion years ago. At that time, everything you can see tonight, the distant stars, the glowing band of the Milky Way, even your own body, was compressed into an extraordinarily small region of space, smaller than a coin. Scientists describe this state as superheated and superdense, a concentration of energy beyond ordinary comprehension. The knowledge gap at the beginning. Modern physics speaks with humility about this earliest instant. We do not yet possess a complete theory capable of describing the exact moment of time zero. When we rewind the universe using Einstein's general relativity, we arrive at a singularity, a point of infinite density and temperature, where the familiar laws of physics cease to function. It is only after Planck time, about 10 to the minus 43 seconds after the beginning, when the universe burned at roughly 10 to the 32 degrees Celsius, that the first outlines of physical reality begin to emerge. At this stage, the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were still woven together as one. The storm of inflation. Almost immediately after the beginning, around 10 to the minus 37 seconds, the universe experienced a dramatic leap known as inflation. In a fleeting fraction of a trillionth of a second, space itself expanded faster than the speed of light. This astonishing growth did more than simply make the universe vast. It resolved deep puzzles that once troubled scientists, explaining why the universe appears uniform in all directions and why the geometry of space is so remarkably flat. Most importantly, inflation preserved tiny quantum ripples, minute fluctuations in energy, freezing them into place as seeds. These seeds would later grow into galaxies, stars, and the grand cosmic structures we observe today. The nuclear cauldron and the dawn of matter. As the inflationary storm subsided, the universe continued to expand at a gentler pace and began to cool. It became a blazing cauldron of pure energy and fundamental particles, restless and dynamic. The triumph of matter, baryogenesis. Within this early chaos lies one of the universe's most profound mysteries, the imbalance between matter and antimatter. In principle, energy should have created both in nearly equal amounts. Yet for every 30 million pairs of matter and antimatter, there was one extra particle of matter. That tiny excess changed everything. Without it, matter and antimatter would have annihilated each other completely, leaving behind nothing but light in an empty cosmos. Our very existence depends on that subtle, almost imperceptible difference. The quark era and the birth of hadrons. About 1/1,000,000th of a second after the Big Bang, as temperatures cooled to around 10 trillion degrees, free-roaming quarks began to bind together. They formed heavier particles known as hadrons, protons and neutrons. This moment marked a decisive turning point, for protons and neutrons would become the foundation of all atomic nuclei, primordial nucleosynthesis. From the first second to roughly the third minute, the universe functioned as a colossal, all-encompassing nuclear reactor. Protons and neutrons fused to form the first atomic nuclei, deuterium, helium, and small traces of lithium. Calculations showed that this process would yield about 75% hydrogen and 25% helium by mass. When astronomers examine ancient clouds of gas today, untouched by later generations of stars, they find precisely these proportions, one of the most compelling confirmations of the Big Bang theory. Rest now. Let these ancient events settle quietly into your thoughts, like distant stars fading into the night. The universe has spoken softly of its beginnings, and for tonight, that is enough. Take a deep breath. Allow your thoughts to grow light, and exhale slowly, as if gravity itself has loosened its hold, and you are gently drifting into a vast, quiet ocean of darkness. Tonight, having journeyed beyond the fiery dawn of cosmic structure, we arrive at one of the most magnificent chapters of all, the Silver River in Infinity, the birth of the Milky Way. This is the story of our shared home in the cosmos, of the silent conductor at its heart, and of the graceful motions of matter that have shaped what ancient observers once called the backbone of the night. Let your mind remain weightless, and allow the symphony of space to carry you toward the most peaceful sleep. The Silver River in the middle of infinity, a map of silence. To understand our place within the Milky Way, imagine this luminous galaxy, home to hundreds of billions of stars, as a single immense pizza. If the entire galaxy were that pizza, then every star visible to the naked eye tonight would fit within a single, narrow slice at its edge. And our solar system? It would be no more than a grain of dust upon the surface. The Milky Way is not shaped by chance. It is a barred spiral galaxy, elegant and deliberate. Seen from above, it resembles a slowly turning windmill. A flat, rotating disk holds most of its stars, gas, and dust, while a dense central bulge glows with tightly packed stars. Beyond this disk lies a faint halo, sprinkled with ancient globular clusters. This graceful, flattened form arises from rotation, while gravity performs its quiet duty, binding everything together, preventing the galaxy from flying apart into the void. The peaceful suburbs, the Orion Cygnus Arm. We do not reside in the crowded and turbulent heart of this galactic city. Instead, our home lies in a calm and spacious suburb, a slender band of stars known as the Orion Cygnus Arm. Here, stars are widely spaced, darkness stretches generously between them, and our sun can shine steadily for billions of years. This location is a rare cosmic blessing. Had life emerged closer to the galactic center, it would have endured relentless radiation from frequent stellar explosions, as well as intense gravitational disturbances capable of disrupting planetary orbits without warning. Our quiet neighborhood has offered stability, the gentle conditions necessary for life to unfold. Silent conquests. The Milky Way you admire tonight did not grow to its vast size by accident. Its history is marked by slow, silent conquests carried out over immense stretches of time. Galactic mergers. From time to time, the Milky Way's gravity draws smaller galaxies toward itself. As they fall inward, their stars are gradually absorbed, becoming part of our galaxy's structure. Astronomers have uncovered clear evidence that many stars in the Milky Way's halo were once members of other galaxies, quietly adopted through these ancient mergers. One such example is the Sagittarius dwarf galaxy, which is even now being drawn into the Milky Way. Each merger adds new material, ignites fresh waves of star formation, and subtly reshapes our galaxy's form. Over billions of years, these gentle yet relentless encounters have built the majestic spiral we call home. Rest now in this knowledge. You are not lost in the universe. You belong to a silver river of stars, flowing calmly through infinity. The silent conductor at the center. Some 26,000 light-years from Earth, concealed behind thick veils of cosmic dust and vast, swirling clouds of gas, lies the very heart of the Milky Way. It is one of the most turbulent and restless regions in our galaxy. And yet, at the center of this chaos rests something profoundly calm. Sagittarius, a star, known quietly as SGR A star. This invisible giant is a supermassive black hole, weighing about 4.3 million times the mass of our Sun, compressed into a region of space smaller than the orbit of Mercury. We cannot see it directly, for black holes emit no light, but its presence is unmistakable. We see it in the graceful yet relentless motions of billions of stars circling an unseen point, bound by an overwhelming gravity. Sagittarius A star is like the conductor of a vast cosmic orchestra, silent, unseen, yet holding every note in place, preventing the galaxy's heart from dissolving into the cold emptiness beyond. Echoes of a violent past, the Fermi bubbles. Today, Sagittarius A star rests in a relatively quiet, almost dormant state. But the galaxy remembers a far more violent chapter. Around 6 million years ago, this calm conductor likely entered a period of intense feeding. Having consumed an excess of matter, it released colossal jets of gas at nearly the speed of light. The remnants of that ancient outburst remain etched into the galaxy as the Fermi bubbles, two enormous lobes of gas filled with gamma radiation, extending some 25,000 light-years above and below the galactic plane. These glowing scars are silent witnesses to a time when the heart of the Milky Way briefly awakened with ferocious power. The Great X-ray smokestacks. In March 2019, the XMM Newton telescope uncovered yet another secret hidden at the galaxy's core. Rising like towering pillars, scientists observed two immense columns of superheated gas emitting X-rays stretching 500 light-years above and below Sagittarius A star. These structures, known as X-ray chimneys, appear to be channels through which excess energy escapes from the black hole's surrounding accretion disk. It is as though the black hole itself is slowly exhaling, releasing pressure built deep within its invisible heart, the ecosystem around the black hole. Contrary to its fearsome reputation, the central black hole is not merely a destroyer. It also serves as a regulator, shaping the delicate balance between birth and death among the stars, a hindrance and a creator. The energetic winds and jets released by Sagittarius. A star can heat surrounding gas until it can no longer collapse to form new stars. This helps explain why star formation near the galactic center is surprisingly low today. Yet paradoxically, those same forces can compress distant clouds of gas, igniting the birth of new stellar generations farther away. It is a quiet equilibrium between heat and cold, suppression and creation, that has sculpted the Milky Way over billions of years. A swarm of shadows, Sagittarius. A star does not rule alone. Observations from the Chandra X-ray Observatory reveal a startling presence nearby, a dense swarm of smaller black holes. Within just 3 light-years of the galactic center, scientists estimate that up to 20,000 stellar mass black holes may be silently orbiting. Drawn inward by a process known as dynamical friction, they sink toward the center, much like stones, settling at the bottom of a calm lake. Unseen, inevitable, and patient. Fountains of antimatter. Among the most mysterious phenomena at the galactic core are vast fountains of antimatter. Each second, this region produces nearly 10 trillion tons of it. When antimatter meets ordinary matter, both vanish in flashes of gamma radiation. Scientists believe this antimatter originates from the radioactive element titanium-44, forged during violent collisions and explosions of white dwarf stars. Even here, in the darkest and most distant heart of our galaxy, quiet fireworks of energy continue, unseen yet relentless. And now, as these images settle softly into your mind, remember this. Even in the most chaotic corners of the cosmos, there is order, balance, and a silent rhythm guiding it all. The loyal dancers and the measure of time. To confirm the presence of the black hole at our galaxy's heart, scientists do not stare into the darkness. Instead, they listen carefully to the light of the stars held captive by its gravity. The death dance of the S-stars. Among these devoted dancers, the star S2 is the most renowned. Once every 16 years, S2 makes a breathtaking plunge toward Sagittarius, a star, passing within a distance of just 17 light hours. At that moment, the black hole's immense gravity flings the star forward at an astonishing speed of 7,650 kilometers per second, so swift that a journey from New York to Los Angeles would take less than half a second. Einstein's quiet confirmation. In 2018, as S2 reached this closest approach, astronomers detected a delicate but profound signal: gravitational redshift. The light escaping from the star was stretched by the extreme gravity it had just endured, subtly shifting toward red. This observation did more than confirm the existence of a supermassive black hole. It offered yet another elegant affirmation that the universe follows the precise and beautiful mathematics envisioned by Einstein, the invisible skeleton of the Milky Way. Beyond the glittering veil of billions of stars lies a structure more vital than anything we can see: dark matter, the backbone of the galaxy. Dark matter makes up about 27% of the universe and serves as the essential framework for cosmic architecture. Without this invisible skeleton, tiny fluctuations in density would never have gathered enough gas and dust to form galaxies at all. The Milky Way is embedded within a vast, nearly spherical halo of dark matter, a deep gravitational well that quietly holds everything together. Here, where you rest. Using modern Bayesian statistical methods, scientists have measured the density of dark matter in our own region of the galaxy, the solar system's neighborhood. At approximately 0.43 plus or minus 0.02 giga-electron volts per cubic centimeter, it is a remarkably precise number. Though unseen and unfelt, dark matter is here with you now, passing through your body every second, silently sustaining the structure of the world around you. The dance of destiny. The distant future. The Milky Way will not dance alone forever. Far beyond our quiet spiral arm, another grand galaxy is approaching: Andromeda. The meeting of two giants. Andromeda is racing toward us at more than 320,000 kilometers per hour. In roughly 4 to 5 billion years, these two great galaxies are expected to begin a majestic merger. This will not be a violent collision in the familiar sense. The vast distances between stars ensure that direct impacts are exceedingly rare. Instead, gravity will slowly unravel the old forms, sending our solar system into new paths within a vast combined galaxy often called Milkomeda, the spiral of two black hearts. At the center of this cosmic encounter, Sagittarius A star and Andromeda's own supermassive black hole will draw together. They will circle one another in a solemn, tightening spiral, releasing gravitational waves that ripple through space-time itself. When they finally merge, an immense surge of energy will be unleashed, giving birth to an even more powerful black hole, the new, steady heart of a transformed galaxy. An open ending, filled with possibility. Yet the future is not written in stone. Recent analyses of data from the Hubble and Gaia telescopes, as of 2025, have introduced a thoughtful note of uncertainty. Scientists now estimate that the chance of a direct merger within the next 10 billion years may be only 50-50. It is possible that the Milky Way and Andromeda will merely pass by one another, continuing their graceful dance for far longer than once imagined. And so, the fate of our galaxy remains an open question, quietly awaiting the next whisper of light to reveal its answer. Our story of the Silver River in the infinite comes gently to a close. You have listened to the heartbeat of the galaxy and witnessed how the black hole at its center is not a meaningless abyss, but a steadfast guardian, quietly guiding billions of stars in a slow, perfect harmony. Night travelers, allow yourself to feel completely safe. You are resting now, in a calm and distant suburb of the cosmos, far from all turmoil. The span of 26,000 light-years is the strongest shield nature has ever placed around you. Everything is exactly where it should be. That great conductor at the center of the Milky Way remains awake, watching over the night, ensuring that every star keeps to its appointed path. The universe is like an endless hourglass. Each falling grain of light carries a story of existence, and tonight, you need do nothing more than lie still, letting that gentle rhythm carry you into deep and peaceful sleep. We have journeyed through the fiery dawn of magnificent structures and listened to the pulse of the Milky Way's dark heart. Now our path turns inward, closer to your own breath. Welcome to A Greeting from the Past, Connection with Earth. This is the story of why you are here, of the quiet gifts the Big Bang placed into every atom of your body, and of the invisible shields that guard the sleep of this small blue planet. Night travelers, relax completely. Close your eyes. Let the symphony of space guide you gently toward rest. A greeting from the past, connection with Earth, a map of silence and cosmic privilege. To begin, let us look once more at our place on the vast map of the Milky Way. Imagine this entire brilliant galaxy as a giant pizza. If the whole galaxy were that pizza, then all the stars visible to the naked eye on a clear night would fit neatly onto a single, tiny slice near the edge. And our solar system? It would be no more than a delicate speck of dust resting on its surface. Our home lies in the peaceful outskirts. We are not residents of the crowded, turbulent city center, where radiation flashes and gravity pulls with relentless force. Instead, we live in a quiet and spacious neighborhood, a thin ribbon of stars known as the Orion Cygnus Arm, sometimes called the local spur. This placement is no accident. It is a rare and precious cosmic privilege. Scientists tell us that this outer region shelters life from the dangers that dominate the galactic core. Had the solar system formed closer to the center, life on Earth would have endured constant exposure to violent stellar explosions, searing streams of gas, and gravitational forces strong enough to disturb planetary orbits without warning. But here, at a gentle distance, the Milky Way has provided a calm sanctuary, one in which life has been able to emerge and evolve for more than 4.5 billion years, largely undisturbed by great cosmic upheavals. The protective distance from the conductor. Earth lies approximately 26,000 light-years from the center of the Milky Way, where the supermassive black hole, Sagittarius A star, resides. Even traveling at the speed of light, it would take 26,000 years to reach that distant heart. This immense separation is nature's most reliable barrier. Despite the powerful X-ray flares and energetic outbursts from Sagittarius A star, our planet remains safely cradled within the calm of distance, close enough to witness the galaxy's grandeur, yet far enough to be untouched by its fury. And so, as you rest here tonight, wrapped in quiet and warmth, remember this: you are not adrift in a hostile universe. You are carefully placed, patiently protected, and gently held by time, by distance, and by the long, thoughtful design of the cosmos itself. We are stardust, a legacy from ancient furnaces. Now let your breathing slow and turn your attention inward toward the quiet miracle of your own body. Have you ever considered that every atom within you did not simply appear by chance? The quiet pride of the light elements. In the moments following the Big Bang, the young universe was composed of only the simplest materials: hydrogen and helium, with a faint trace of lithium. These were the first building blocks of existence. Yet on their own, they were far too modest to shape a world of bones and blood, forests and flowing water. The forges hidden in the depths. The heavier elements essential to life, carbon, oxygen, calcium, iron, were born much later, deep within the burning hearts of massive stars, or forged in the violent brilliance of supernova explosions. When these great stars reached the end of their long lives, they did not vanish quietly. They broke apart, scattering their enriched ashes into the vast darkness between stars. About 4.6 billion years ago, a cloud formed from the remnants of these ancient stellar generations began to collapse. From that cloud, the sun and its planets were born. And so, the calcium in your bones, the iron in your blood, and even the gold resting gently against your skin all carry the memory of stars that once shone, lived, and sacrificed themselves billions of years ago. You are quite literally a continuation of the Big Bang, a living legacy of ancient light, resting peacefully within your own heartbeat. The solar system, a seed, germinating in the darkest night. Imagine the birth of the solar system, a process lasting millions of years, yet unfolding softly within the vast calm of cosmic time. The quiet collapse of a molecular cloud. It began in a dense pocket of a giant molecular cloud, perhaps stirred by the distant shock wave of a supernova. The cloud slowly yielded to its own gravity. As it contracted, it spun faster, warming at its center, like a lone dancer turning more quickly beneath a single growing spotlight. The protoplanetary disk and the birth of worlds. Most of the material gathered at the center, igniting into the young sun. What remained flattened into a broad, rotating disk of gas and dust. Within this disk, tiny grains met and clung together, growing into stones, then into planetary seeds. Close to the sun, only rock and metal could endure, giving rise to Mercury, Venus, Earth, and Mars. Farther out, in the cooler reaches, gas and ice accumulated into giants like Jupiter and Saturn. Earth and the Moon, a bond forged in impact. Around 4.5 billion years ago, Earth experienced a defining moment. A body roughly the size of Mars collided with our young planet. From that immense impact, a vast ring of debris formed, slowly gathering into the Moon. This quiet companion not only softens our night skies, but stabilizes Earth's rotation, shapes the tides, and gently regulates the climate, faithfully for billions of years. Shields protecting life. Though the universe is vast and beautiful, it is also filled with radiation and high-energy danger. Yet Earth has been granted remarkable layers of protection. The sun's protective bubble, the heliosphere. The sun gives more than light. It releases powerful streams of charged particles, forming a vast protective bubble known as the heliosphere. This invisible shield deflects much of the harmful cosmic radiation from interstellar space, like a strong shelter, standing firm in a relentless storm. Earth's magnetic heart, the magnetosphere. Deep beneath your feet, molten iron flows within Earth's core, generating a powerful magnetic field. This field reaches far into space, guiding solar winds away from our atmosphere. Because of it, we can breathe freely and witness the quiet beauty of auroras dancing at the poles. The atmosphere, a gentle blanket. And finally, the atmosphere itself, thin, delicate, yet immensely strong. It holds warmth close, filters harmful ultraviolet light, burns away small meteors, and sustains every breath you take. Everything is precisely where it belongs, subtly shaped by the laws set in motion at the dawn of time. And so tonight, as you rest, remember this. You are not exposed to a hostile universe. You are carefully sheltered by ancient light, by gravity, by magnetism, and by a world designed over billions of years to cradle your sleep. The last dance and rebirth. Now, allow your thoughts to drift gently into the far future, to a time when the Milky Way itself prepares to turn another page in its long and patient story. The reunion with Andromeda. Our Milky Way is not alone in the cosmic night. Far beyond our stars, its great neighbor, the Andromeda Galaxy, moves steadily toward us at more than 320,000 kilometers per hour. In 4 to 5 billion years, these two ancient galaxies will begin an encounter of extraordinary scale. Yet the latest studies, drawing on Hubble and Gaia data in 2025, suggest a quieter possibility. The chance of a direct collision is only about 50%. Instead of a violent meeting, the two galaxies may simply pass one another, bound in a long, graceful gravitational dance. The union of giants. Should a merger occur, it will not resemble destruction as we imagine it. The distances between stars are so vast that actual stellar collisions are unlikely. What will change is the shape, the slow, patient reshaping by gravity. Old structures will loosen, new ones will emerge, and from this encounter, a larger, brighter galaxy will be born, Milkomeda. At its core, Sagittarius, a star, and Andromeda's own central black hole will eventually find one another, circling in a solemn embrace before merging into a single, even more powerful presence, the heart of a reborn galaxy, the fate of the Sun and Earth. By then, our Sun will also be nearing the final chapters of its life. It will expand into a red giant, its outer layers swelling outward, possibly consuming the inner planets. But this lies unimaginably far in the future. It is not a tragedy, only the universe continuing its quiet habit of renewal, transforming the old into the seeds of worlds yet to come. Our story of a greeting from the past comes to rest here. You have witnessed how darkness and light, destruction and creation have always moved together, woven into the fabric of existence. From the Great Bang 13.8 billion years ago to the gentle warmth surrounding you now, everything belongs to one unbroken symphony. Now, let thoughts of swirling galaxies and immense black holes slowly dissolve. Feel the calm certainty that you are protected by invisible shields, nourished by ancient stardust, and held steady by the silent conductor at the galaxy's heart. The universe is like an endless hourglass. Each falling grain of stardust carries a story. Tonight, you no longer need to count them. Simply rest and listen to the quiet rhythm of time itself. Relax your body completely. Let your eyelids grow heavy. Drift softly into sleep, wrapped in the gentle, silken currents of the Milky Way. Sleep well, traveler of the night. The universe is watching over your dreams.